Hey guys, welcome back. So in the last video, we saw an example of all the three types of notations, that is omega, big O and theta. Hope the concept was clear. Now in this video, let's see some of the examples of algorithm runtime complexities. So in the world of algorithms, there can be multiple time complexities. But here, for the sake of example, we are taking the most commonly used complexities out of those. So the first time complexity is order of 1. It is also called as constant time complexity. Now one of the examples where we can achieve a constant time complexity is adding an element at the front of a linked list. Now the second time complexity is order of log n. It is called logarithmic time complexity. Like finding an array in a sorted array using a binary search is a classical example of logarithmic time complexity. Now the third type of complexity is order of n. It is called a linear time complexity. Now if we want to find an element in an unsorted array, that is a good example of linear time complexity. Now the fourth type of complexity is order n log n. This is also called as linear logarithmic time complexity. So merge sort is a great example of linear logarithmic time complexity. The next type of time complexity is order n square. It is also called quadratic time complexity. Now if we are given a graph and we want to find out the shortest path between two nodes, then this can be achieved in order n square. The next complexity is order n cube. It is also called cubic time complexity. Like if you want to multiply a matrix, this requires order n cube time. Now the last time complexity is order 2 to the power n. It is also called as exponential time complexity. So Tower of Hanoi is a standard problem, and to solve that problem it requires order 2 to the power n complexity. Now please don't worry if you don't understand lot of these examples out here, like what is merge sort, what is matrix multiplication, or what is shortest path in a graph. We are going to talk about all of these things as we progress with the course. So as of now, please just hang on. You need not understand each of the things that is given here in example. As we progress, we will understand each and every one of them. Fine. So now let's see how does all these 7 time complexities, if plotted on a graph, looks like. So this will give us a very fair idea about which complexity requires how much time. Now here we have a graph. On a x-axis we have given elements, which is nothing but the number of inputs that is provided to the algorithm. Whereas on the y-axis we have operations that is performed using that algorithm. So as we can see, order of 1 is a constant time complexity, hence it does not depend on the number of elements. Hence we don't see it in this graph. So if we are processing, let's say 100 elements, it will take order 1 unit of time. Or if we want to process 40 elements, still it will take order of 1 time. Hence, with the increase in number of elements, the time complexity does not increases. It always remains constant, that is order of 1. So here we have a thin line which is in blue color, which is not visible right now, but we have it here under this red line, indicating that whatever be the number of elements, the operation always remains constant, that is 1. Now if we go to the second time complexity, it is order log of n. So we see that log n is represented with a red line over here. Similarly, order of n, this line over here represented in green. Order n log n is represented with purple, and so on. Now as we can see that order of log n, that is the red line, taking so less of operations for performing 100 elements. Whereas if the time complexity is order of n, which is represented by green line, takes around 100 operations. But in case the time complexity is order n log n, the operation becomes somewhere 650 for the same 100 elements. Now if you see, we have n square represented by blue color. So only for around 35 elements it is taking 1000 plus operations. And orange and the light blue color takes even more time compared to the other operations. So I hope this gives you a fair idea about how one time complexity comparison to other time complexity does so much of difference in terms of the time that it takes. Fine, so that was all about some of the examples of algorithm runtime complexities. Now with this, we will end this video. In the next video, let's talk about how to calculate algorithm runtime complexity for a given algorithm. Thanks for your time. See you in the next video.